Okay, so we're starting with Barron's 2, number 25. Okay, and we're doing inverses. Okay, so I have f of x. I have a point that it goes through. It says that f inverse, and I want f inverse prime at 2. Okay, so who is this? Oh, good job, guys. He's the y. Who is the x that goes with that y? Good job. So now I'm going to do 1 over f prime of 1. So 1 over, what's f prime? To the 4th plus 3. Plug in a 1, and what do you get? Okay, now, Andrew, you asked a really good question. You said, what if they didn't give us this point? Then I would take this 2, which is a what? A y. And I would take that, is that a minus 2? And set it equal to 2. Now, I'm going to subtract the 2 over and get this. Anybody know how to solve that? It's not quadratic formula. I can't factor it. It's not a complete the square. He's not quadratic. I don't know how to solve things that are to the 5th power, but I could graph him and find his solution by figuring out where he crosses the x-axis. Then he crosses dead on at 1. Okay? Look on your formula sheet. He is always the y. When it asks for f prime of the inverse, that number that's in there is a y. See how it says g prime of y, and g is f's inverse. It's always a y. Okay, where are we headed? Princeton 1, so that's blue. 34. Mason, we did that one twice. You can get the answer. Princeton 1, 34. Okay, it gives me f of x. It says that g of x is what? The inverse of f of x, and it wants g prime of 10. What is the 10? He is a y. Now, if he is a y, what do I need? I need the x. Did it give it to me? No. So here we go. Take your function and do what with it? Set it equal to 10 because the 10 is the y. Okay, now how would you solve that? Subtract the 10 over. It's quadratic. I got to get them equal to 0. Okay, now what? Three x and x. 5 and 2. That gives me 5 and a 6 on a negative 6. So negative 2 and positive 5. Which gives me a negative 5/3 and a positive 2. Okay. Which one's nicer? Okay, let's try the 2. All right, so what do I plug this into? 1 over the derivative of f of x, which is, okay, now plug a 2 into that. Okay, now what if I plugged the negative 5/3 in? Plug a negative 5/3 in here, so 1 over 6 times negative 5/3. Okay, 3 goes into 6 2 times. 2 times negative 5 is a negative 10. Minus 1 is a negative 1 over 11. Is that a choice? No, but it is a valid answer. But it's not a choice. And they could never have both because they're both good answers. Okay? All right, is that it for inverses? Okay, so that's it for inverses. You have 1 for homework. Okay, and I'll tell you what that number is later. Okay, what's next? Aaron 1, 23. So green 23. I feel like we're playing bingo. Green, 23. Or football. Barron 1, 23. Okay, read it. Okay, this one takes some work. Nicely enough, number 24, when we get to that one, doesn't take a lot of work. So, but y'all see, this is all 23. Okay, so you can use the side of that paper and feel free to go on down. Okay, use it because 24 doesn't need the space. Okay, I want the tangent line to, well, no, this one's not going to take that much work. I want the tangent line to estimate the value at 3.1. You see this word right here? That's the kicker. Estimate. What on your formula sheet? Yeah. Y'all see it? Okay, what's that formula? F of x plus delta x. And what this means is f of something nice plus the extra crap that makes it not nice equals f of x plus f prime of x delta x. And every time you write that formula, like, let it come back in your mind, okay? Just go ahead and start memorizing it. Okay, so I want 3.1. Well, what's nice that's close to 3.1? Okay, so I'm going to let x be 3. What's my delta x going to be? 0.1. And remember, your delta x can be negative. Like if it was 2.9, I'd still be a 3, but my delta x would be a negative 0.1. Okay? So what I need to do is I need to find f of 3, because 3 is my x, plus f prime of 3 times, what's my delta x? Okay, so let's find f of 3 first. F of 3. I got to plug a 3 in for all my x's and solve for y. And they did, look. Oh, that's so nice of them. 3, 0. So if x is 3, y is, but if you plug in a 3, you still get a 0. Okay, so f of 3 is 0 plus, oh, no, because, yeah, no. Yeah, f of 3. So he's x, he's y. Yes. If, like I said, if you plug a 3 in here and solve for y, you'll get tangent of y equals 0, which happens at 0. So y is 0. Or you just use the point. 3 and a...
Like when you subtract it.
Yep. You get a 0, and then you may have a 3 and divide it over, you get a 0, but then you got to find out where tangent of y equals 0 to solve for y. And tangent of y is 0 at 0. Remember, y over x. Okay. Woo. Plus, all right, now what do I need? I need f prime. So I got to take the derivative of this sucker. Implicit. Okay, here we go. What do we got? 3x squared. Again, with me, not 5 seconds behind me, which most of you are. Stay with me. 3x squared plus, all right, now I got a product rule. X, good, secant squared y dy dx plus tangent y equals 0. Okay, plug in what for x and what for y? 3 for x and 0 for y. Good. So 3 squared is 9. 9 times 3 is 27. Plus 3 times secant squared of 0 dy dx, or you could change that to y prime, plus tangent of 0 equals 0. Now I'm solving for dy dx. Okay, so I'm just going to leave my 27 here for a second. What's secant squared of 0? Okay, where's 0? Here he is. Secant squared is who? Flipped. Cosine flipped, cosine's x. So 1 squared, which is 1, dy dx. Okay, what's tangent at 0? Y over x, so 0 over 1, which is 0. Okay, subtract your 27 over and divide by 3. So negative 9. Y'all go with that? So who is that? That's f prime of 3 times 0.1. Y'all see it? So what do you get? Yeah, negative 0.9. So it all stems off of a cute, nice, simple formula. Derivative on this one got a little hairy. But the formula itself, does everybody see the formula? All right, take 2 seconds and memorize it. F prime of x plus, no, f of x plus f prime of x times delta x. F of x plus f prime of x delta x. All right, Tilly, where are we headed? Baron 2, number 4. Okay, this one takes some space. Do y'all want to grab like a sheet of paper to maybe put in between some of these pages to give you some space? If you want some, or are y'all going to... Anybody? One second. Or you could go on the back, right there. You don't have that on. You okay? You okay? Oh, you want one? I couldn't tell. The coat's throwing me off today. Okay, what do we say? Baron 2. Okay. All right, here we go. Use the line tangent to that at x equals 0 to find an estimate of f of 0.06. Got it? Everybody sees the word estimate. Okay, I'm writing out my formula. Of course. All right, f of x plus delta x. F of x, f prime of x, delta x. We got it? I got the formula? Okay, so I'm f of, what am I, 0.06. Really close to who? What nice number is that close to? 0. 1 minus 0.94. Okay, so now I'm going f of 0 plus f prime of 0 times 0.06. Okay. f of 0. If I stick a 0 in the original function, 9 plus sine of 2 times 0 is 0. What is sine of 0? 0. So this is, what's the square root of 9? There you go. That's it. Okay, now this is usually the messy part. I got to go take my original function, and I got to find his what? Derivative. Okay, so pretend that's all to the 1/2. So we're going to go power rule with a chain rule. With a chain rule. Y'all see the two chains? Okay, so what do we got? What's out front? 1/2 9 plus sine 2x to the negative 1/2 times, okay, derivative of the inside. Well, the derivative of 9 is 0. Sine would be cosine of 2x times 2. Good. Okay, take your little guys and clean them up. So that'd be a 1, right? Your 1/2 and your 2. So I am 9 plus sine 2x to the negative 1/2 cosine 2x. Okay, so that is my derivative. What do I do with that? Plug a 0 in for my x's. So this is going to be 9 plus sine 0 to the negative 1/2 cosine of 0. Okay, what's sine of 0? 0, so it leaves me with a 9. The 9 is to the negative 1/2, 1/3. Cosine of 0 is 1. So all that mess is a 1/3 times 0.06. Then you grab your handy dandy calculator. This is inactive. 3 plus 1/3 times, write that as a fraction. 6 over 100. So 3 plus 1/50th. Check me. Is that right? What are we? Oh, and we're in decimals. Of course we are. 1/50th would be 200ths. Right. Leave that, instead of 1/50th, leave that as 2 over 100. Y'all see it? So D. Y'all okay? Okay. Do we have any more of those? Which one? Fair and 3. Gold, 15. It's not boxed in? Okay. Okay, everybody sees the word estimate, right? Okay. So, write out your formula. This one's not bad because it's not a trig. Like his derivative is minor. It's not hairy. Princeton, you got tons of room, but it's Barron's that are might not hurt to put just slice of paper in between each. Okay, so let's see. Who's x and who's delta x? 0.2. I think the one y'all have to do for homework, your delta x has got to be a negative. It's like, I don't know, 3.9 or something. So you go 4 and a negative 0.1. Okay, so I need f of 2. That'd be 20. Oh, no. No, look. Read. Do y'all see it? Read. That's g prime. Like, they're already giving me the derivative. But then look at what they gave me at the beginning. G of 2 is 5. Now look, if I hadn't stopped and read, we would have been plugging 2 into the derivative. I know. Okay, so that is your public service announcement for reading the question carefully. So I'm going to plug in a 2. I'm going to get a 5. Okay, 5. Now, f prime of x, which they've already found for me, so plug a 2 in there. You're getting 20 over 9 minus 4, which is so 4 times 0.2, 5 plus 0.8, right? Another decimal in one place. So 5 plus 0.8 is? All right, is that it for approximation?
Yeah.
Okay.
Now we're B2, 38.
B2, so pink, 38. What's our topic? Ah, tangent lines. Oh God, and they start off with a doozy too. B2 38. Okay, this is calculator active, by the way. This part right here. Okay, talk to me about how to find the slope of a tangent line at any point on any graph. Find the derivative. That is the derivative's job. He has one job, and it is to find you the slope of the tangent line at any point. That's why he exists. That's his sole purpose in life, is to find you the slope of the tangent line. Okay? Now, I am finding the slope of the tangent line at 2 of the arc tangent of the natural log of x whole shebang squared. Now, what is an arc tangent? Tangent inverse. So you have a tangent inverse of a natural log. Okay, now I need to take the derivative of this sucker, right? And I'm going to do what once I take the derivative of this sucker? I'm going to plug a 2 in, and that's going to tell me what its slope is. Grab a calculator. Go to math. See down there where it says derivative? Y'all see it? Okay, hit enter. Okay, now plug in tangent inverse. Well, I think you need to start with parentheses because we've got to square the whole thing. So start with parentheses, then go tangent inverse of ln of x, close like 1,000 parentheses, and then square it. And then if you have the new operating system at the bottom, like on the bottom right corner, it's asking you where you want to evaluate it at. So if you can go down there, you can stick in a 2. Mm-mm. Oh.
I'll put an X. Yeah. X. But what about that? What about that?
Okay, Baron 3, 39. The tangent line to the graph of the function f, I don't even know what f is. At the point 8, 1, that intersects the y-axis at 3. I want to find f prime at 8. And my point is 8, 1, right? So I want the tangent line at this point. Isn't that what that's saying? Find me the slope of the tangent line at that point. I don't have a function to take a derivative of. What is derivative's purpose in life? Slope of the tangent line. Guys, you've been doing slope since 7th grade. Gave you a point. Technically, I'm giving you another point. If I hit the y-axis at 3, isn't that a point? What point? Then can't you take those 2 points and just go find me the slope? Y minus y over x minus x. If that's not a nitty-gritty roll up your sleeves kind of problem, that's a do you understand the concept question. Say it again. But it's also the slope of the tangent line at that one particular point. Don't overthink. You're really good at that. All right, Andrew. Help him. You're fine. Princeton 1. So we're blue 13. Princeton 1, 13. This is a good one. Like a good, solid, not a super tricky, just a good, solid problem. Thank you. Slope of the tangent line to the graph of that at 2, 1. The slope of the tangent line. What does that mean? Find the derivative. What kind of differentiation do we have going on here? Implicit. Ready? Go. 6x plus 5 is a constant. 5 dov over of, guys. dy dx equals again, try writing with me or maybe even a slightly bit ahead of me, not behind me. I gave you a point, 2, 1. Shove it in there. 12 plus 5 times 1, 5, dy dx equals 0. Subtract your 12, divide by 5. Negative 12 over 5. Love those. Love, 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 love those. Princeton 2, so you're yellow. 17. Princeton 2. 17. Okay, now this one is not just wanting the slope of the tangent line, it wants the equation of the tangent line. So this guy, of course, hold on. Remember him? Okay. So we're going to find the slope, which is what we just did in the last problem. And then I'm going to take my slope and the point that they gave me and plug all that mess into x and y1. And then I just got to clean it up to make it look like they want it to look. Okay? Okay, so first things first, let's find the slope. So I need the derivative. Okay? What you got? 18x plus 32y. I'm going to go y prime. Are y'all okay with that? I mean, you can go dy dx, but equals 0. Plug in. Now be careful you don't plug anything in for y prime. The dy dx does help us not try to plug anything in for that. 18 times 2, 36 plus negative 32, y prime equals 0. Subtract the 36 over, and then divide by negative 32. Reduce by 4. 9 over 8. Everybody okay? Okay, so who is that? That's m. That's your slope. Okay, so I'm going to take my slope, and I'm going to take the point they gave me, and I'm going to plug it into here, and here, and here. So y, good, plus 1 equals 9 over 8 x minus 2. Well, they definitely didn't stop there. Let's distribute. So 9 over 8x minus 2 and the 8 would cancel, so 9 over 4. Okay, now I'm going to stop right here and notice that they have no fractions in their answer. So can we kill that right now? What would you need to multiply by to make all your fractions go away? What's your common denominator? 8. Oh, yeah, that. So I'm going to give him an 8. I'm going to give him an 8. He doesn't need an 8. And I'm going to give him an 8, which is going to multiply the top by 2. Okay, now it wants, all the answers have everything on the left-hand side. So I need to move the 9x, and it looks like they put their x's in the front. So I'm going to scoot the 9x to the front, so negative 9x, then plus my 8y. Then I'm going to add the 18 over here, 18 and 8, 26 equals 0. Negative 9 in the front looks like A. But what's wrong with A? A has a negative 26. I have a positive 26. So what have they done? They ran a negative through. So I need a positive 9x, a negative 8y, and a negative 26. There you go. That's just them being little turds about how they want their answer. That's it. That's all that is. All right, Andrew. Good job, buddy.
That was quick.
That was quick. He's quick on the draw. Okay, 22 has a new word. Guess what normal means? Normal means you're perpendicular to the tangent line. So take your slope that you're going to find normally and go perpendicular with it. How do you go perpendicular? Change the sign and flip it. So both things. Okay. So here we go. I need derivative. Huh? What?
Oh,
What are y'all doing? Okay. dy dx. No, you got to stop. Okay, so dy dx equals, there's your 1, plus, oh, nope, minus sine of xy, and then you got to go, I know, x dy dx plus 1y. Okay. Can we plug? Or, I mean, can we plug before we clean? I just think it's easier. Okay, so again, I'm going y prime because, you know. All right, now that would be minus sine of 0. Okay, well, what's sine of 0? Hello? What does that do to that whole chunk out there? He's all gone. Love that. So what's your slope? 1. Okay, but that's the slope of the tangent line. I'm not tangent, I'm normal. So I'm negative 1. Everybody agree with that? We flipped it, but when you flip a 1 over 1, you still get a 1 over 1. But I do have to change its sign. Okay, so what's normal? Perpendicular to the tangent line. Good. Very good. All right, next. Princeton 3, number 12. Princeton 3, number 12. Okay. Everything not normal. I don't want to use that word. Everything straightforward. Okay, go. Oh. Power 4. I got a 1 for my slope. Okay, so we are either A or B because they both have a slope of 1, right? Okay, now what is my x? Pi over 4. Well, they both have x minus pi over 4. So I need to figure out the y that goes with that x at the derivative or at the original. Good, at the original. So take your pi over 4, plug it in here because I need his y. So sine squared pi over 4, that's your 45. So what's sine at the 45? Root 2 over 2. And I got to square them because it's sine squared. So 2 over 4, which is 1/2. So I'm liking him. Okay, Andrew. Say it again. 34. There we go. Okay, we got f of x equals 3 to the x. For what value of x is the slope of the line tangent to the curve at x, f of x equal to 1? For what value is the slope of the tangent line equal to 1? Where is the slope of the tangent line equal to 1? So find the equation of the tangent line, set it equal to 1, and solve it. Y'all see that? Okay, so take the derivative, 3 to the x times 1 times ln of 3, and set that equal to 1. Okay, so I got to solve for x. Can I move stuff? Can I divide by ln of 3? I mean, because that's a constant, right? So 3 to the x equals 1 over ln of 3. Now what? Log base 3. Log base 3 of 1 over ln of 3 equals, that's your snail. Okay, do y'all remember how to do this? tall, small. Do y'all remember tall, small? Grab your calculator. You're going to do log of 1 over ln of 3, close the parentheses, divided by log of 3. It's called the change of base, but we nicknamed him tall, small. Answer C. Are we getting him? Tall, small. Okay, Andrew? Where are we going? That was 34. Was it C? Did you get C? Okay. Which of the following is the equation of the tangent to the graph of that at 3? Okay. I need, do we need to get an X? We got a Y. Do we need to get an X? Don't we need an X to go with him? Maybe not. Let's find the derivative first, because I don't think y'all would have done that. Y prime equals 3x squared plus 2x. Everybody agree with that? Okay, now I'm ready to plug in. What am I going to plug in? I need an X. Y'all see now that we need an X? Okay, so I have that y equals 3. So I know that x cubed plus x squared equals 3. Now, even if I subtract the 3 over, isn't that cubic? Do we know how to solve that? We have a calculator. Go graph him. To save time, can I just tell you where he crosses? Okay. Does everybody know you go like second calc and you go down to zeros and you find where he crosses? He crosses at 1.175. It's not pretty. So then, bless you. So then I go 3 times 1.175 squared plus 2 times 1.175. And you get, I'm going to tell you, bless you again, m equals 6.492. Am I going too fast? Okay, so that's my slope. What was my point? 1.175 comma 3. Okay, so y minus equals x minus. Okay, well, what the crap? What did they do? They have distributed, they have cleaned. Can we trust that we could do that? Distribute that sucker and clean them up, and you get C. Okay, let me see. Where are we? That was 41. Okay, but that's perfect. We'll just save mean value theorem for later. Okay. Okay, so correct. So your homework is Barron's 1 number. I'm going to put this up here. Y'all just want to take a picture of it? Okay, Barron's 1, but look, it's not much. Then the extra, number 31. Then Barron 3, number 4. Princeton 1, number 8. Princeton 2, number 10. Princeton 3, 31. And the extra, 14. This is tangent lines. This is your estimation. And there's your inverse. Y'all got it? Oh, I like the word tangent. That looks good. Hold on. Okay.